Hello everyone. So continuing on from simultaneous equations, we're going to look at quadratic simultaneous equations. This is when we have more than one x squared or y squared term. So to do this, we're going to do something called the substitution method. Yesterday, I taught how to do the elimination method, and you can use the substitution method for linear equations. The substitution method works through anything, and you'll see how. So, okay, let's first of all look at an example, right? We're told that y is equal to 2x minus 4, and this is 2x plus 3y is equal to 6, right? What is the point of intersection going to be? What we're going to do is we're going to substitute in one for the other. So y is equal to 2x minus 4, right? And 2x plus 3y is equal to 6. What you can see is that y is equal to something in terms of x. So all we're going to do is substitute this into y. So what we're left with is 2x plus 3 times 2x minus 4 is equal to 6. And now what we do is we solve for x. So let's expand the brackets because that's a problem. 2x plus 6x minus 3 times minus 4 is minus 12 is equal to 6. Let's add the like terms. So 8x is equal to 8x minus 12 is equal to 6. Let's add the 6 onto the other side. So 8x is equal to 18. And so x is equal to 18 over 8, which can be simplified to 9 over 4. And now, just like our previous solution, previous video, we're going to substitute this in for x. So y is equal to 9 over 4 times 2 minus 4. And when we pop that into our calculator, we should get an answer of 0.5. And so these are our two solutions. So this point here, we can say is 9 over 4, 0.5. And so we've solved the question. But you usually use this method when you do quadratic simultaneous equations, like shown. So, how would we solve y equals x squared minus 3x plus 4 and y minus x is equal to 1? Well, the first thing we need to do is we need to make y the subject. You can make x the subject, it's just a little bit easier to make y the subject in this case. And you'll see why in the next example. So let's make y the subject. Make y the subject. So y is equal to x minus, no, it's plus 1. It's definitely plus 1. And now we're going to substitute this x plus 1 in here. So therefore we can write y equals x squared minus 3x plus 4 as x plus 1 is equal to x squared minus 3x plus 4. And now what's the rule for a quadratic? We need to make it equal to 0. So let's minus x and minus 1. So we're left with x squared minus 4x plus 3 is equal to 0. And now we think of two numbers that add to make -4, but multiply to make +3. What two numbers do that? Exactly. -3 and -1. So now we're left with x is equal to either 3 or 1. So we should have 2x and 2y solutions. Now, notice how we've already written out that y is equal to x plus 1, which means that there's no other algebra that needs to be done. All we need to do is just substitute one of these one at a time. So let's start with y1. So when x is equal to 3, y is going to be equal to 3 plus 1, which is equal to 4. So if x1 is equal to 3, y1 is equal to 4. And finally, when x2 is equal to 1, y2 is going to be equal to 1 plus 1, which is equal to 2. So if x1 is equal to 3, y1 is equal to 4. And if x1 is equal to 1, y1 is equal to 2. And those are our solutions. But what about if we have both x squared and y squared, and it's equal to 34? How do we do something like this? Well, first we make either x or y the subject. In this case, they give us y is equal to x plus 2. So we sub in x plus 2 into y. So we're left with x squared plus, and then we sub in y, which is x plus 2, all squared. And we're told it's equal to 34. Okay, sure. And now, what are we going to do? We need to make it equal to 0. So let's expand the bracket first. So x squared plus, and then what we're told that x plus 2 and x plus 2 is the same as x squared plus 4x plus 4. So we're just going to put that in here. X squared plus 4x plus 4 is equal to 34. And then let's collect the like terms. So 2x squared plus 4x plus 4 is equal to 34. And then let's minus 34 on each side. I'm going to do this in a different color because I just realized how monotone my page looks. Yes, that's right. My page looks monotone. And so we're left with 2x squared plus 4x minus 30 is equal to 0. Now, how do we expand these brackets, factorize this type of equation? Well, let's multiply 2 and minus 30, which is minus 60. So now let's think of two numbers that add to make minus 60, but multiply, adds to make plus 4, but multiply to make 60, minus 60. And those two numbers are 10 and minus 6. So we can rewrite this as 2x squared plus 10x minus 6x minus 30 is equal to 0. And so therefore, we can factorize these two and those two. We can factorize 2x out. So 2x times x plus 5 minus 6. We can factorize out minus 6 times x minus 5, no, x plus 5, it will be x plus 5, is equal to 0. And then because these two are the same, we can just make this 2x minus 6 a double bracket. And so what we're left with is x1 is equal to minus 5. I'm just going to let it be that one. And then if you remember how we did it before, we need to make this equal 0. So 2x minus 6 is equal to 0. So therefore 2x is equal to 6. X is equal to 3. Sorry, my page is a bit all over the place. And remember, because we're told that y is equal to... We're told y is equal to x plus 2. So now, let's sub in each of these. So x1 is going to be... y1 is going to be... Pental y is equal to minus 5 plus 2. Which is equal to, what's minus 5 plus 2? Minus 5 plus 2 is simply going to be equal to minus 3. So then we can write it out. When x is minus 5, y is minus 3. And then for our second solution, y is equal to 3 plus 2. What's 3 plus 2? 5. And so when x is 3, y is simply going to be equal to 5. And that is our final solution. Thank you guys for watching. I hope that this made sense to you. If you guys liked it, please subscribe. It means the world. If you guys need some individual help, join my Discord server and I'll help you as best as I can. And finally, if you guys need some extra tutoring, drop me an email and we can organize a free meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.